In a certain college, 25% of students failed maths, 15% of students failed chemistry, and 10% of students failed both maths and chemistry. A student is selected at random. Part 1. Find the probability of M, the probability that the student failed maths. So if we imagine that the number of students in the college is 100, then 25 of these failed maths. Thus, the probability of picking a student who failed maths is 25 over 100, or 0.25. So the probability of M, that the student failed maths, is 0.25. Part 2. Find the probability of C given M, which is the probability that the student failed chemistry given that he or she failed maths. So next up is to identify C, which is those students who fail chemistry, and then M intersection C, which is those who failed both maths and chemistry. We are told that 10% of students failed both. So the probability of M intersection C, that the student failed both maths and chemistry, is 10%, which is 0.1. Then, by the definition of conditional probability, which is the probability of B given A is equal to the probability of A intersection B divided by the probability of A, which is the probability of A and B divided by the probability of A. So we're going to rewrite this formula using C and M. So the probability of C given M is going to be the probability of the intersection of M and C divided by the probability of M. So it's basically whatever we are given, the probability of that becomes our denominator, and the intersection becomes our numerator. So whatever we are given becomes our denominator. So the probability of M intersection C is 0.1, so that's our numerator. The probability of M is 0.25, so that's our denominator, which simplifies to 2 over 5. So the probability of C given M, the probability of the student failing chemistry given that they failed maths, is 2 over 5. 3 cards are chosen at random from a standard pack of 52 cards. What is the probability that all 3 cards chosen are clubs, given that exactly 2 of the chosen cards are known to be picture cards? Picture cards being Jack, Queen, or King. So we're going to let A be the event that we are told has happened, and let B be the event that we want to find the probability of. Because all choices of 3 cards are equally likely, we only need to count outcomes. So, event A is exactly 2 of the cards are picture cards. So this is what we were given, this is what we were told in the question. Given that exactly 2 of the chosen cards are known to be picture cards. So we need to rewrite this mathematically. So 2 of the cards are picture cards. So this means choose 2 from 12 picture cards and 1 from the 40 other cards. So 52 take away 12 leaves us with 40 cards. So choosing 2 from 12 picture cards is really 12 choose 2, and means multiply. Choosing 1 from the 40 other cards is 40 choose 1. This gives us 66 times 40, which is 2,640. Now we have to take event B, which is that they are all clubs. So we are asked to find the probability that all 3 cards are clubs. This is what we want to find, so this becomes event B. Next, we want to find the intersection of A and B. We're not actually interested in the probability of B, just the probability of the intersection. So the intersection, or basically A and B, is that exactly 2 are picture cards and all are clubs. So once we have our English sentence, we want to rewrite that using probability terminology, and then we put it into maths. So exactly 2 are picture cards and all are clubs really means choose 2 from 3 club picture cards and 1 from the 10 other clubs. So we know there are 13 clubs altogether in any pack, and we know that 3 of them are picture cards. So the king of clubs, the queen of clubs, and the jack of clubs. So we want to choose 2 from the 3 club picture cards, which is 3, choose 2, and multiply 1 from the 10 other clubs. 13 take away 3 leaves us with 10 other clubs. So 10, choose 1. That's 3 times 10, which is 30. Now we use our formula. So we know that all the events are equally likely. We can choose any card from the pack of 52. So we're going to use this formula. So the probability of B given A is the number of elements in the intersection divided by the number of elements in A. So we have 30 divided by 2,640, which is going to be 1 over 88. So the probability that all 3 cards are clubs, given that exactly 2 of the chosen cards are known to be picture cards, is 1 over 88.